This video is for Advanced Algebra, Lesson 7.1 on power functions. Students will need to use a baby calculator for some of the questions and graphing calculator for others. Power functions are problems that have a base number raised to a power. So that's what the two boxes here are supposed to reference, and that's what the arm here is supposed to reference as well. The base is the bicep, and then the fist is the power. And so you can see here that when you have a base labeled here as an x, raised to a power, the n, those are referred to as power functions or power equations. When you raise something to a power, there are two results. The power could either be an even number or an odd number. And so when you separate it out as being even versus odd, there are two different results that you're going to see. The even-powered power functions are parabolic in shape. Know that the x to the second is the only one that's officially labeled as a parabola. The other ones look like a parabola, and so they're called parabolic. When something is parabolic in shape, that means it has even symmetry, and that simply means that it has symmetry that is symmetric to the y-axis vertically. And we'll look at that when we scroll down here and look at the graphs in just a second. When you're working with an odd power, that graph will have two halves of a parabola, but those two halves will be pointing in opposite directions. So you'll get more of a squiggly or curvy shaped line for that graph. Graphs that have an odd power will have odd symmetry, which simply means it's going to have 180-degree rotational symmetry, or another way to describe it is it's symmetric about the origin. So let's go ahead and take a look at what those graphs look like. And so you'll see that when you're working with an even power and your base is a positive value, so we'll say positive x raised to an n where n is even, you're going to get a parabolic shaped graph. So one half of the parabola is going to go up to the right, the other half will go up to the left. And so you'll be in quadrants 1 and 2. Now when the x value happens to be a negative number, when the power is even, then the parabola flips over, or the parabolic shaped graph will flip over and point downwards. And so the domain of those graphs are going to be all reals. Remember that the domain is the x values, so x can either be clearly positive or negative, so that's all real numbers. And the r with the double bar there is the symbol you can use to abbreviate all reals. The range here is either going to be positive, if you're looking at the graph vertically, it's either going to be positive reals when x is a positive or negative reals when x is a negative. So we'll say positive reals or negative reals. Symbol-wise, you would say y is greater than or equal to 0 for positive reals, or you could say y is less than or equal to 0 if you're saying negative reals. You could say it in words or you could say it in symbols. And again, the quadrants here would be quadrants 1 and 2, or quadrants 3 and 4. The only one of these graphs that ends up having a specific name is the parabola, and the parabola comes from the squaring function. So only x squared has a specific name, which we call the squaring function. There may be names for the others, like x to the 4th or x to the 6th, but the only one that students need to know for this course is the squaring. The coordinates in common we're going to save until we've finished talking about the odd powers. So we'll come back to that last item here in just a moment. Odd-shaped graphs, or odd-powered graphs, are going to have one side of the parabola, similar to what we had in the original parabola for evens, but the other half of it won't mimic it on the left, it'll actually curve and turn down the other direction. So when you're doing odd powers, you're going to be in quadrants 1 and 3 when x is a positive value. When x is negative and being raised to an odd power, then you'll be in quadrants 2 and 4. So the domain here is going to be the same as it was for the even powers. It's still going to be all reals, but a difference now is that the range is not just positive or negative because the graph goes up or down forever, so the range is also going to be all reals when it's odd. The quadrants here are either going to be 1 and 3 or 2 and 4. The only one that students need to memorize by name is the cubic function when you have y equals x to the 3. Now the points that are in common to both of these graphs, I want students to take a moment to think it through. Points that are going to be in common to both, if you look at both graphs, are definitely going to be 0, 0. If you take 0 as your base, as your x, and raise it to a power, don't you always get 0 back? So 0 and 0 is common to both of these. There is one other point that is in common to both. If you think about taking a number and raising it to a power, whether it's even or odd, the only one that that's going to make sense for is 1. When you take 1 and raise it to a second or to a third, you're always just going to get 1 back. So 0, 0 and 1, 1 are common to both of these graphs. Now let's go ahead and try some real-life situations that involve powers. Probability tends to be something that we talk about when we talk about powers, because probability raised to a power is how we do the probability of an independent event. So this yellow box here was taken from page 454 in the textbook. If an event has probability p, and each occurrence of the event is independent of the others, then the probability that the event occurs n times is p to the n. So p is your probability, n is the number of times that probability occurs. So that looks like a power function, a base raised to a power. So let's put that into practice now with a specific problem. A spinner has 4 congruent sectors. Remember that congruent means same size, same shape, like the one pictured. Assume the spinner is fair, which is redundant because we already know that the sectors are congruent. What is the probability of landing on yellow 5 times in 5 spins? So again, this is a power function, or a power function question. So we need to figure out the base and the exponent. The base is going to be the probability of landing on yellow. Yellow is 1 out of the 4 sectors, so we'd say 1/4 for the probability. Or you could say 0.25. And then the n is the number of times the event occurs. They tell us to spin it 5 times, so that's going to be our power. So I put the little caret symbol there to mean that I'm raising it to the 5th. Keep in mind that that 1/4, both the top and the bottom are being raised to the 5th, so if you need to, you might want to include parentheses there. So if you were asked to do this question with a baby calc, you would want to do it in fraction form. That'll make your life easier. If you are allowed to use a graphing calculator, then you'd probably just want to do the decimal version. So depending upon what tools you're allowed to use, you could either do it in fraction or decimal form. When you do it in decimal form on the calculator, you get 0.000977. And so you'd want to pay attention to what to round to. If they give you that specifically, you'd want to make sure to round to the proper number. When you do it with a baby calc, you'd want to take that fraction and multiply it by itself 5 times. And so all the 1's on the top are still going to make a 1. And then 4 times 4 times 4 times 4 times 4, you'd want to figure that out on the baby calculator very carefully. And when you do that, you get 1024. So depending upon what tools you're allowed to use, you could either answer it with a decimal or a fraction answer. Let's try another one similar to that. George forgot to study for a quiz. The quiz has 5 multiple choice questions, each with 4 choices, and 5 true-false questions. Find the probability that he guesses and gets all of them correct. This one has 2 elements, and so since we have 2 different types of problems we're working with, we're going to multiply the results together. So we're really doing p to the n times another p to the n here. So know that that might happen on word problems where students have multiple probabilities that they're going to combine by multiplication. So first let's start with the multiple choice, and then let's do the true-false. So the multiple choice questions, first figure out the p, the probability of one of the questions. So each choice has 4 options, so that means the probability of the multiple choice is 1/4, just like we did with the spinner question. There are 5 of those, so that's going to be our power. So we know that that's going to be 1/1024. Then we're going to multiply that by the probability for the true-false. True-false only have 2 options, so that's a 50% outcome or a 1/2 for the probability. There are 5 of those, so that's going to be raised to the 5th as well. This would be a graphing calculator question. Students would be allowed to use either a graphing calculator or a scientific to come up with the answer here. It's going to be a very small decimal, so a calculator would be necessary. When you type all that in, you're going to get 0.0000 4 zeros, and then a 3, 1. So obviously it's a very small probability that you would guess blindly on a question or on a quiz like this. Another type of question that students might see that's related to powers, not necessarily related to probability, is one like the next one here. Since 2 to the 8th is 256, calculate 2 to the 9th without a calculator. I like to do this question visually. If you think about what 2 to the 8th is, it means 2 times 2 times 2, 8 times. So I'm going to write all that out so I can visually see it. So there's 8 2's that are being multiplied together. And I know that that result, as a group, is going to turn into a 256. They're asking me, however, to figure out 2 to the 9. 2 to the 9th means 9 of these multiplied together. So since I have the first 8 already listed, all I need to do is multiply by an additional 2. Now I have 9. Since I know that 256 is what the first 8 make, all I need to do is 256 times 2, and that'll tell me what 2 to the 9th is. And multiplying by 2 is super easy. I just double everything, so I know that that's going to be a 512. So I didn't need a calculator to do that one. Students should be prepared for questions like this. All that's going to change is what's given. Maybe the base will turn into a 3, power will turn into something else. They'll just ask you what the next one would be. One final question that students need to be comfortable doing is taking a graph, utilizing the graph's shape, and the one coordinate that's given to try to come up with an equation. So our equation is going to look like y equals x to the n. Our job is to figure out what that power is supposed to be. Every equation has an x and a y in it. So all you have to do is utilize the information given to find what the missing power is. Based on the shape of the graph, I can see that it is not a parabola or parabolic shaped graph. So I know that that power must be odd. And again, that's because of the shape of the graph. So the shape tells you one piece of information that is useful. I know it's going to be x to something odd. Then the other piece of information they give me is a coordinate. Remember that coordinates have an x component and a y component, which is lucky because I have an x and a y in my equation. So I'm going to use those numbers to help me find the missing exponent. So I know I've got 2 as my base because that's the x. I don't know the power. And let me just write this a little differently here. I'm going to put the equals y on the other side. So 2 is my base for x. I don't know the power, and I'm trying to get to 8192. So now I'm going to do just a little bit of trial and error to try to figure out 2 to the what power is 8192. Now I know that when I'm doing my trial and error, I'm going to only utilize numbers that are odd. I know that 2 to the 3 is going to be way too small, so I'm going to start with 2 to the 5th. And I'm going to type that in my calculator and see if I get 8192. If it doesn't work, or if I don't get what I'm looking for, I'm going to try the next one up, like 2 to the 7. I'm skipping 2 to the 6th because I know it's not even. And so when I do my trial and error over and over again, I've tried all of these, and it's not until I get to 2 to the 13 that I get the one that I'm looking for. So what's the missing power? 13. So now let's write an equation that matches that. So for my final answer now, I'm going to say y equals x to the 13.